Hello everyone, welcome back. Today we are going to discuss the difference between TCP and UDP. Well, to understand that, we first need to grasp the concept of protocols. Imagine protocols as a set of rules or guidelines that determine how data is sent and received over the internet. They are like the traffic rules of the information superhighway, ensuring that data gets from point A to point B efficiently and correctly. Now, among these sets of rules are two main protocols that govern most of the data transmission on the web. These are the Transmission Control Protocol, commonly known as TCP, and the User Datagram Protocol, or UDP for short. They each have their unique characteristics and uses, making them suitable for different kinds of data transmission. Now that you've got a basic understanding of what protocols are and the role they play, let's delve into what TCP and UDP really are. TCP, or Transmission Control Protocol, is a connection-oriented protocol. This means that before any data transfer begins, a connection is established between the sender and the receiver. It's like making a phone call. You don't start talking until the other person has picked up and you're sure they're on the line. Now let's delve a bit deeper into the characteristics of TCP. One of the key features of TCP is its reliability. It ensures the delivery of packets from sender to receiver. You can think of packets as small parcels of data, just like letters or packages you'd send through the mail. TCP is like a diligent mail carrier, ensuring every packet is delivered to the right address. But TCP doesn't just deliver these packets, it also maintains the order of transmission. So, if you're sending a series of packets, TCP makes sure they arrive in the same order they were sent. Imagine mailing a 3-part novel to a friend. You wouldn't want them to read the last part first, would you? This is where TCP steps in, making sure every packet, or in this case, every part of the novel, arrives in the correct sequence. Another significant feature of TCP is its ability to manage traffic congestion. When the network gets congested, TCP can reduce the rate of data transmission to prevent packet loss. It's like a traffic cop, directing the flow of data to avoid any network pileups. TCP is typically used in applications where reliability is crucial. For instance, web browsing, email, and file transfers all use TCP. These are applications where it's critical that information is delivered accurately and in order, so TCP is like a reliable postman who makes sure your letters arrive in order and intact. But what about UDP? UDP, or User Datagram Protocol, is a connectionless protocol. This might sound a little perplexing, so let's break it down. Unlike its counterpart TCP, which we discussed earlier, UDP doesn't establish a connection before data transfer. It's like tossing a message in a bottle into the sea, hoping it'll reach its destination. Let's delve into the key characteristics of UDP. The first characteristic is that UDP doesn't guarantee delivery. The message is sent out, and that's it. There's no mechanism for checking if the message reached its destination. It's like sending a letter without a return address. If it gets lost in the mail, there's no way for it to find its way back to you. The second characteristic is that UDP doesn't maintain order. If you're sending multiple data packets, they might not arrive in the order they were sent. It's as if you're sending a 3-part joke, but the punchline arrives before the setup. The joke still gets there, but it might not make sense to the receiver. The third characteristic is that UDP doesn't manage traffic congestion. If the network is busy, UDP doesn't slow down or wait its turn. It just sends the data out, potentially causing congestion. It's like a vehicle that doesn't slow down in heavy traffic, weaving through cars and potentially causing chaos. However, despite these seemingly negative characteristics, UDP has its advantages. The most notable one is its speed. Because it doesn't need to establish a connection, guarantee delivery, maintain order, or manage congestion, it can send data much faster than TCP. This makes UDP ideal for applications where speed is paramount, such as streaming services, online gaming, and live broadcasts. In these situations, a few lost or out-of-order packets are acceptable trade-offs for a smoother, faster experience. If a few frames are dropped during a live sports broadcast, for instance, it's preferable to having the entire broadcast lag due to TCP's slower, more reliable data transmission. In comparison, UDP is like a speedy courier who delivers your packages as quickly as possible, but can't guarantee they'll arrive in order or even at all. You might be wondering, how does this all add up? Well, let's dive into the key differences between TCP and UDP to get a clearer picture. Firstly, TCP, or Transmission Control Protocol, is like the meticulous friend who double-checks everything. It's reliable, ensuring that all data packets reach their destination in the correct order and without errors. If a packet goes missing or arrives damaged, TCP will request a replacement. This reliability, however, comes at a cost. TCP is slower because it spends time making sure everything is perfect. It's like a careful postman who makes sure every letter is delivered to the right mailbox, even if it takes a bit more time. Additionally, TCP has a built-in traffic management system. It can sense if the network is congested and slow down the data transfer rate to prevent a gridlock. This is another feature that contributes to its slower speed but ensures smoother and more organized data transfer. On the other hand, UDP, or User Datagram Protocol, is like the friend who's always in a rush. It's faster because it doesn't bother with the checks and balances that TCP does. UDP sends data packets without any guarantee of their delivery or order. It's like a quick courier who drops off the package at the door and rushes off to the next delivery without waiting to see if anyone's home. UDP doesn't have a congestion management system either. It keeps sending data regardless of the network conditions. This can lead to packet loss or delay, especially in congested networks, but the speed of data transfer is generally faster. So, to sum it up, TCP is like a careful but slow postman, while UDP is a quick but less reliable courier. Both have their unique roles and applications in the realm of internet communication. Some applications prioritize reliability and order, while others need speed. Depending on the requirements, either TCP or UDP is chosen to make sure our data gets from point A to point B in the vast digital universe. Thanks for watching, and please subscribe to this channel.